The science is not equal to the scientific method. I'm going to elucidate on this point because part of my own minor scientific method has been saying certain things over and over again and then seeing if I've actually managed to communicate what I'm trying to say to people. And also keeping in mind that not everyone is watching every single video on my channel. This might be the first video you find on this channel or wherever I'm posting this, and if so, welcome. And if you've been here before, welcome back. Subscribe if you haven't subscribed yet and you're in a platform that can subscribe. Thinking of starting maybe podcast because some of these videos don't really need the visuals on it. But with this one, I'm going to be reading something from Science Buddies. I've been recently making some videos and posting content about the troubling or interesting or just this thing that I've observed with society, a lot of people calling to believe the science. Trust the science. What does the science say? Oh, is that from the science? And then extending that to the scientists. Oh, the scientists say this. The experts on the science have said this. The experts have provided this. This is what the science says. This is a consensus of what the science says. And I'm trying to make the distinction between the science and the scientific method. I'm trying to point out that when people talk about the science, they do not necessarily have a knowledge or awareness of the scientific method that might have actually been behind achieving that thing they refer to as the science. Certain things that are not that rigorously scientific are being attributed to the science, or someone will expect a certain issue to be able to just be solved by the science, when if you actually asked them or actually looked into any actual scientific method that has been applied to that thing, you will find it to be lacking, or their understanding of the system will be lacking. So I'd like to make this video so I can also refer back to it if it comes up again in another situation when somebody's saying, oh, you're anti-science, or you're against the science, oh, you don't think science should do this for that. Like, no, I am a fan of the scientific method. It has brought a lot of beautiful and amazing things to my life and the world in general, and it will be what makes a better world for us in the future. It is currently the best way that I know in order to get to know and believe as many true things as possible and as few false things as possible. And that's borrowed from Matt Dillahunty, but I think it's an excellent thing to say, and I am on board with that. I am a complete amateur at this science. I'm not a scientist, but I can read this material and I think I understand this. And this website is there, sciencebuddies.org. You can go there and get this information, and there's also other links in there that help you expand on it. There's other sources out there, but this is information that's available for all of us, thanks to a lot of people engaging in the actual scientific method and developing a platform to share this with us. Okay, so let's go. I'm just going to read through. Steps of the scientific method. What is the scientific method? The scientific method is a process for experimentation that is used to explore observations and answer questions. Does this mean all scientists follow exactly this process? No. Some areas of science can be more easily tested than others. For example, scientists studying how stars change as they age or how dinosaurs digested their food cannot fast forward a star's life by a million years or run medical exams on feeding dinosaurs to test their hypotheses. When direct experimentation is not possible, scientists modify the scientific method. In fact, there are probably as many versions of the scientific method as they are scientists. But even when modified, the goal remains the same: to discover cause and effect relationships by asking questions, carefully gathering and examining the evidence, and seeing if all the available information can be combined into a logical answer. Even though we show the scientific method as a series of steps, keep in mind that new information or thinking might cause a scientist to back up and repeat steps at any point during the process. A process like the scientific method that involves such backing up and repeating is called an iterative process. Whether you are doing a science fair project, a classroom science activity, independent research, or any other hands-on science inquiry, understanding the steps of the scientific method will help you focus your scientific questions and work through your observations and data to answer the questions as well as possible. Here is now a graph of it that just goes in the steps. I'm going to just kind of read it as well as I can. It's going to be on the screen, and as I mentioned, there will be a link to this site for you to actually check it out yourself. It's at sciencebuddies.org. So first is ask a question, then it's followed by do background research, then it's construct a hypothesis, then test with an experiment, then you ask is the procedure working? If the procedure isn't working, you troubleshoot and the procedure and carefully check all steps and setup. Then you go back to test with an experiment, and then you see if the procedure is working. If the procedure is working, then you analyze data and draw conclusions. Then if the results align partially or not at all with the hypotheses, the next option could be experimental data becomes background research for a new future project to ask new questions, form new hypotheses, and experiment again. Then you go back to construct that hypothesis, and you come back to test with an experiment, procedure working, yes or no, then analyze new data with conclusions. Then the other one is if the results align with the hypotheses, or again, if the results align partially or not at all with the hypotheses, you can then communicate the results. Now I'm going to go into more of a breakdown of the steps of the scientific method. Step 1. Ask a question. The scientific method starts when you ask a question about something you observe. How, what, when, who, which, why, or where. For a science fair project, some teachers require that the question be something you can measure, preferably with a number. For detailed help with the step, use these resources. Here's about your question and the laboratory notebook. Some more information here. This is part of Google Classroom. It has a link to that, to Teacher Toolbox. This is a learning tool. This is something that can be used to actually teach people. So they're going to be talking about other resources and things, and it's targeted towards teachers, but I think anyone can stand to learn this. It's good to just keep in mind and understand this. And there's just so many different ways of actually learning out there that I find my major issue is people just seem to say this is what is accepted. This is the way things are supposed to be. We're supposed to learn by sending kids to public school instead of testing and seeing what's the scientific method behind showing is this really the best way to teach a child. Now, might it be the best way to teach average children, maybe the most children? If that's what you're saying, then make a case for that. But to say it's for every child, no. I would like them to be more of a process where you see different kids are going to ask in different ways. Ask the question, what is the best way for my child to learn? It might not be the same as average kids. It might not be public school in the way that it's done, the compulsory public school. Okay, going back to the next step. Do background research. Rather than starting from scratch and putting together a plan for answering your question, you want to be a savvy scientist using library and internet research to help you find the best way to do things and ensure that you don't repeat mistakes from the past. For detailed help with this step, use these resources: background research plan, finding information, bibliography, research paper. The next step, construct a hypothesis. A hypothesis is an educated guess about how things work. It's an attempt to answer your question with an explanation that can be tested. A good hypothesis allows you to then make a prediction. And here's an example of the prediction. Quote, if I do this, then this will happen. End quote. State both your hypothesis and the resulting prediction you will be testing. Predictions must be easy to measure. For detailed help with this step, use these resources: variables, variables for beginners, hypothesis. I'm currently recording this during a pandemic, and that has been part of why I've been posting a lot about the science, because a lot of things have been thrown around this. And I think there is a raised awareness on and I think there's been a rise in awareness of what the scientific method can and cannot do. Maybe not the cannot do. I think a lot more is being actually attributed to it. But there's a lot of things that are being I don't want to tested for the first time. There's a lot of things that people had hypotheses of what would happen. That with some people, I think they're like, oh, if this happened, let's try to have a shutdown and see what happens. But now that the shutdown has happened in a lot of places, I think now there's actually a lot of people who can hypothesize that, oh, if I did this with my life, then this would happen. And they're getting to test it out. If my kids weren't going to school, then this would happen. They would not be able to learn. Some people are figuring out, oh no, they're actually able to learn. Some people used to say, if I was able to just work from home, I would be able to be much more productive. And then now they're actually getting to find out that, oh, maybe that's not quite the case. They're actually testing it out. Some people thought, oh, if this horrible thing was supposedly happening to us, we have this system that's set up for us to recognize, identify, and actually deal with that issue and protect me in an accurate way. And unfortunately for some people, well, unfortunately at the current time, because I think people are realizing that's not the case, but that doesn't mean that need goes away, and that doesn't mean we can't find better ways to achieve those actual protections, identifications, and institutions and structures. We still can, but it's good to let go of the things that we had in the past and head to new things. Okay, next one. Test your hypothesis by doing an experiment. Your experiment tests whether your prediction is accurate and thus your hypothesis is supported or not. It is important for your experiment to be a fair test. You conduct a fair test by making sure that you change only one factor at a time while keeping all the other conditions the same. You should also repeat your experiments several times to make sure that the first results weren't just an accident. For detailed help with this step, use these resources: experimental procedure, materials list, conducting an experiment. On to the next part. Analyze your data and draw a conclusion. Once your experiment is complete, you collect your measurements and analyze them to see if they support your hypothesis or not. Scientists often find that their predictions were not accurate and their hypothesis was not supported. And in such cases, they will communicate the results of their experiment and then go back and construct a new hypothesis and prediction based on the information they learned during their experiment. This starts much of the process of the scientific method over again. Even if they find that their hypothesis was not supported, they may want to test it again in a new way. For detailed help with this step, use these resources: data analysis and graphs, and conclusions. Another aside here before I get to the final point in this is my main frustration with people who have said things. I understand faith is still considered a virtue. It's still considered something that should be respected and is something valid to say, I just have faith in this, I just have a belief in this, and actually make life decisions off of it. But we don't have to do that anymore, especially on certain contemporary things. When this information comes out, you actually have the ability to go to the source material itself and check the actual data that's there. You may have a layman's approach to it. You may not be an expert in some of this, but I have been able to go and see actual data in actual places and say, I don't necessarily understand this thing, so I'm not really accepting the actual conclusion that's being made. Or you can actually see the kind of data that's being provided and see there are some things that are not necessarily actually being mentioned on the actual reports by media or other people who are talking about this. What is the base level of understanding you require from somebody saying something? Or do you require to believe something is valid? Or do you just listen to what the experts say about the science? Okay, on to the next and last one. 6. Communicate your results. To complete your science fair project, you will communicate your results to others in a final report and/or display board. Professional scientists do almost exactly the same thing by publishing their final report in a scientific journal or by presenting their results on a poster or during a talk at a scientific meeting. In a science fair, judges are interested in your findings regardless of whether or not they support your original hypothesis. For detailed help with this step, use these resources: final report, abstract, display board, and science fair judging. So that's it for this site. You can see it's done towards schooling, and I mentioned my questions and issues with actual schooling. I don't have a problem with education. My objection is that the schooling system is not the best way. Most of the schooling systems we see all over the world, the most popular ones, especially the mandatory public schooling ones, are not the most conducive environment for actually educating children or anybody. Why should it be limited to children? I think something like there's good things about it. Like the sporting systems, there's good things about that, bringing camaraderie, learning teamwork, learning different ways to actually win and lose, even if people are working towards the same things. The actual socialization, when it's done in a positive way, is a positive thing, but there's also a lot of fights. There's a lot of reasons to have, school counselors, because it's not all just kumbaya in there. There's bullying and all these other issues that are in there as well, different kinds of assault and things like this. Some of this stems from the actual home environments that some of these people have. You may have a great home environment for your child, but you put them in a public school that's mandatory for you to go to. Some other kid might, unfortunately for that child, have a horrible home life, but then that child takes it out on your kid, and that's not something your kid would have been exposed to if you had more of a control on who your kid is actually exposed to at that risky and tender time in their actual childhood development. Something that was mentioned here with actual science fairs. I think science fairs are rather cool to have. This is something where it can be done in the private sector. Same thing with the actual sports. That can be done in the private sector as well. You can have something like this where it's just open, where people can join from any actual ages and different groups. If you just feel, oh, there's going to be a science fair studying this thing in this environment, let's just go join the science fair. You can have kids in school age, and then you can have adults, you can have people in college, you can have actual big time scientists who decide, hey, let me just join this and do this thing because I remember doing it when I was a kid and I think I have a more interesting way to do it now, and let me go do it. And then that way the community just gets to work together with people of different ages. You share different interests, look at novel ways of looking at things. You have actual importance and encouragement of the actual scientists out there going along with the scientific process. Because with some of these fields, you have these entrenched groups, these sort of mafias of sorts, where they just come in and there's a cabal of them. They control what's actually happening, what can actually be said. Not all scientific fields are the same, scientific pursuits and studies. Some things are harder to test. There could be peer review in chemistry that's rather direct. For example, you just get something like a 100% oxygen environment or close to 100%, over 95% oxygen environment, and you test the effect of that on basic crabgrass, and you can do that test over and over again. It is rather simple to do and repeat and duplicate. But when you get into something like psychology, you get into something like social sciences, where there's many different variables. There was a reproducibility project on psychology led by Brian Nosek of the University of Virginia, where they found out that out of the 100 ones, the 100 tests that were attempted to be repeated, I think it was done in international effort, including 270 scientists. They ran other people's studies, and over half of them were not able to be duplicated. Now that's with people because there's different actual variables of the people. How can you actually get this same person to take this same test when people have such varied backgrounds and mentalities and influences and time is constantly changing? Then you have situations like with a virus. The virus itself, as it's mentioned in this latest pandemic, it was a novel coronavirus. It comes from a strain of virus that is familiar, so you can take some of the tests and hypotheses and things that have been found out from other testing on it, other information available on it, but doesn't necessarily apply to this particular iteration or type of this virus. Then the virus itself mutates. The way people react to it changes. So there's a lot of different variables to go in. It was mentioned in this before about talking about things a lot far in the past, testing the actual dietary process of dinosaurs, or just greater, grander scale things like looking into the future and saying this is what the climate is going to be at this time. There's a lot that can change to alter these things. There's a lot of things. Some things are just out of our control to actually get a lot of solid information on it, but people treat it, the science, as a sort of faith, like it's just coming from this all-knowing being that is just completely irrefutable. If this person is actually saying it, if it comes from the science, it must be correct, it must be valid, when that is not necessarily the case. So yes, the climate is changing. Yes, there are actual issues in society that are involved with treating of certain groups in certain ways that have lasting effects on those groups, on the members of those groups. Yes, there is an actual virus out there in the world that is relatively new, that has been now added to the ways that we can die, and there's steps to take to prevent the deaths to be as high as they possibly could be, because this thing has no compunctions in killing as many people as possible. All it says is replicate, 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 and that replicating process involves death, death, death. But that's it for now. I hope I have made my point. I am not against the scientific method. I encourage people to know more about the scientific method. I encourage them to actually use the scientific method in other parts of their life. It is a method. It is not an actual thing by itself that is completely alien that you can't actually use. It is just a method that I think quantifies and qualifies and organizes and systemizes something that most people do anyway. A kid is like, oh, look at that. That looks kind of cool. Like, why is that flickering this way? You put your finger in it. Oh my God, it's a fire. I'm not going to touch that again. That's some kind of scientific process. It looks cool. I wonder what it feels like. Oh, that's hot. That's burning. I do not like that. I'm not going to do that again. Let's see if I can place this in the 6 steps here. So ask the question. The kid sees the things like, oh, that's cool. It looks kind of cool. Yeah, I wonder what that. I wonder what that feels like. I wonder what that is. Then somebody says, do background research. What's the background research? Oh, have I seen it before? Yeah, maybe I've seen it before. I've seen the adults around it, these other bigger creatures, and they seem to be familiar around it. They seem to get rather close to it without getting direct harm. But okay, let me see if, so it's not completely dangerous in and of itself. I'm not supposed to just not be around it. So you construct a hypothesis. If these people are around it somehow, maybe I can get close to it too and gain something from it. You test the hypothesis by doing an experiment, that's putting your finger in the flame. Oh, that is too close. That is too hot. I'm not going to do it again. That's the analyzing your data and you drawing a conclusion. I'm not going to do that. And then maybe you're communicating your results by crying. That might communicate to other people around you that have done this and it hasn't worked, like this thing is bad. Or maybe it's a situation where crying somehow makes more of an indelible actual memory in your mind that this is something I shouldn't do. So this is just a mini scientific process that we do from the start of interacting with things. It is part of what makes us human. This is a key part to the human condition. So I want us to embrace it, but I want us to embrace as solid and as positive of a scientific method as possible and not reduce it to an object of faith, not reduce it to just a simple belief system. Let's not do this. This is something that has raised us from that and will take us to this next level, this upgrade, this sort of leveling up of the human species, of earthlings, of just life in general, life that we know of. Okay, that's it for now. It's part of my shorty series. It's also going to be in the read series. Anyway, got different videos and things posting up. I got a couple of things loaded up. So just, if you like what I was saying here, please do like. If you disliked what I said here, I don't know why you dislike the scientific method. Maybe you dislike some of the things I said about it. Also dislike if you did. Let me know what you think in the comment section. There's also links to a merchandise store. I'm definitely going to put up the science is not equal to the scientific method on that. I'm actually going to go open up Illustrator right now and create that graphic and upload it. So by the time I actually upload this video, that will be the actual shirts and merchandise that is on the actual screen right now as I say this. There's also links below to PayPal if you'd like to help use one-time donation. I have done a scientific method and I've found out that I do like money because it does enable me to do a lot of other things in my life that I consider positive. So that's it. Till next time, goodbye.